Hi everyone. Today we're going to begin module 19. So 19.1, we're going to take a look at the graph of sine and cosine graphs that involve stretching, compressing, or reflecting sine and cosine graphs. So we are going to begin day 1 today, and we will be able to graph the basic sine and cosine functions at the end of the day. So let's take a look at some recall information. This is a review from previous module. We called that the points around the unit circle have the coordinates of cosine and sine. So remember that each point is starts with cosine and then sine. So you can think of it as x, y, alphabetical order, C before S. So that's how you can remember it also. So the first one is cosine and second one is sine. And that's a quick review. And let's take a look at also another review. This is the unit circle. So these are all of the values. And remember that last module we went through and we derived the 30, 45, and 60 sine, cosine, and tangent values of all of these. So that's where these values are still at. So we're going to be using some of these key points from the unit circle. So we're going to be paying attention. We are going to look at the graph of sine and cosine. And remember, again, sine is the second value in these, and then cosine is the first value in these coordinates. So do not get those confused. So we will be looking at the two graphs that are relating to these values individually. So that's what we're going to do. So let's take a look at the basic sine function. So if you look at the values from this unit circle, we have some key marks for the actual values for the sine. So when sine is at 0, when the degree is at 0, we are looking at the sine, which is 0. So we're getting that number right off of the unit circle here. So we're going to go ahead and fill out the value of 0 for sine. And then we're also going to take a look at pi over 6. So pi over 6 sine value is what? 1/2, right? So we're going to fill that out. So far, so good. Next, we have pi over 4, which is like 45 degrees. So that's going to be radical 2 over 2. And if you actually convert these, it will mean more because it'll tell you like what's the value. So we'll write that as 0.5, and if you divide radical 2 over 2, you should get about 0.707. And then next is pi over 3, and the sine value is radical 3 over 2. And if you divide that, you should get 0.866. And then at the pi over 2 mark, which is right here at the 90 degree, the sine is at 1. So that's a 1. And if we keep going, 2 pi over 3 for sine is going to be radical 3 over 2 again, which is the same as the one above. So it's 0.707. So that's a repeat. And actually, I might have gotten the wrong number here. Let's take a look at it again. 2 pi over 3. So 2 pi over 3 is radical 3 over 2, and it should be 0.866. And then 3 pi over 4, which is the radical 2 over 2, should now be 0.707. And then 5 pi over 6, we are getting it from here again, which is 1/2. So 1/2 or 0.5. And then at the pi mark, it's a special one. It's on the line. So sine is the second number, which gives us 0. And if we keep going like this, I'm just going to write the rest of the answer. So you can just refer to the chart for these values right here. So at the 3 pi over 2, notice that sine is -1. So that's what I have. And continuing again on the chart. And again, you can just refer to the chart for those values. And finally, coming back at 2 pi, which is the same as 0, it gives me a 0. So that's a repeat. So if you look at these values, you notice that the values of sine start with 0, and then it increases, goes all the way up to 1, and then it goes down, down, and then goes to 0, and then start going down some more, and then going to the lowest point, which is -1, and then coming back up to 0. So there's a pattern. If you graph all of these points, do we really need all of this to make like the graph? So if we graph all of these, you would actually have all of these like little dots, like this, that would actually make a graph looks like this. So do we really need all of these points to make a sine graph? That's an interesting question. The answer is no. Notice that if we recognize the key points, then we should be able to get the basic graph. So if you look at the graph of sine itself, you don't really need all of the points that we have here. Like there would be, if we actually want to kind of map up the, picture the approximate graph, these are the points that we will need. So notice those are the points that are actually highlighted yellow right here. So that's 1, 2, 3, 4, and 5. So those are the actual 5 key points. We call those the key points, or we have also called these points reference points. So maybe you're more familiar with the term reference points. So if you actually just only use those points and graph those, we would be able to get a better picture, or actually a pretty good picture of sine. So let's go ahead and draw those right here. So I'm going to cut up the graph. Notice we are graphing from 0 to 2 pi, right? And then stopping at the in-between. So we got 0 and then 2 pi. Halfway would be pi. And then halfway over here would be pi over 2. And that's 3 pi over 2. So those are the 5 basic points. And if we take the y value and just graph those, so at 0, it's going to be 0. So we have a point at 0, 0. And then at pi over 2, it's going to be 1, which is right there. And then at pi, it's going to be 0. And then at 3 pi over 2, it's going to be -1. And then finally, back at 2 pi, it's going to be 0 again. So these are the main points which make up the graph of sine. So if we connect it, this is 1 period of pi. And notice that this graph will keep going, so we need to have those arrows at the end to indicate that the graph does not stop there. Because if you actually look at the graph, if you enter y equals sine of x into decimals, you will have a continuous graph that looks something like this. And the graph just keeps going, and it does not stop there. So that's why this is only 1 period, and we're going to talk about what that is later on. So this is the graph of a sine. Something that is interesting is that sine starts with S, right? So if you want to help yourself remember better, just think of it as S for sine and S for snake. Did you notice that the graph of the sine is kind of like the shape of a snake? So that is how you can remember sine and snake. Sine graph looks like a snake. Okay, and so here is a summary. Again, here's how we can memorize. The sine is in the shape of a snake right here. And the 5 key points that we went over earlier are right here. So those make the 5 points, the key points. And 3 of them, you notice, 3 of them actually touch the x-axis. So those are the 3 x-intercepts. And then the other 2, one is called the maximum point and one is called the minimum. It's a local max, local minimum. So those are the 5 special points that make up sine. And so again, those values come from this chart right here, the unit circle, right? For the cosine, for the sine. But now we're going to take a look at cosine. If I follow the graph one more time and start with the value of cosine, remember cosine is the first number in everything. So we're going to take a look at these values right here. So you're going to be obtaining every single one of these from the graph here and transfer it over to this chart. So starting with 0, the graph, the value of sine of 0 is actually 1. So we're going to put 1 there. And once again, at pi over 6, it's going to be radical 3 over 2, which is 0.866. And then pi over 4 is going to be pi over 2 over 2, which is 0.707. And so again, you find the same pattern. You can go back and forth here and refer to those values, but I'm not going to go back and forth here. Otherwise, you will go dizzy by me doing that. So I'm just going to transfer those values and you can just refer to them. Okay, so here they are. 707, negative 866, and then negative 1. And we have negative back to 866, and then negative 707, negative half, 0, half, 707, and then 866. Finally, the last point for the cosine is going to end up at 2 pi, once again, is at 1. So the last value is 1. So notice again, we have the 5 key points here. So notice the x values do not change for the key point. It's still at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so what does the graph look like when you graph this? Do we again need all of these points? Once again, you do not need those, and we're only going to be using the 5 key points that are highlighted here. And when we do that, we will have the cosine. So let me go ahead once again, start with the graphing. So that's going to be 0 to 2 pi again. The minimum is 0, 1 period, and the maximum is at 2 pi for the x value. And also the cosine function, minimum is at -1, maximum is at 1, and then halfway again are those other 2 points. So we got 3 actually we got 5 key points once again, but if we take the key points, we will have 0, 1. So at 0 it is 1. Let's take a look at what the graph of the cosine look like. At pi over 2 is going to be half. So at 0, 1, and then pi over 2 is 0. Pi over 2 is going to be 0. And then at pi is going to be at -1. So we have pi, -1. And then the next one is 3 pi over 2, 0. So at 3 pi over 2, it is 0. And finally, 2 pi is going to be at 1. So those are the 5 key points. So we're back at 1 over here. So if we connect those, I use a different color. So if you connect these, does it still look like a snake, guys? No, it does not look like a snake. In fact, this is not a snake. This is the cosine. That's why it looks different than the sine function that we had earlier. So something that you guys may notice, that this graph generally looks like the shape of a cup. So we can use cosine starts with C and cup starts with C to kind of memorize or remember how the graph looked like for cosine. So it looks like the shape of a cup. And here's another summary again for the 5 key points. 1, 2, 3, 4, 5. Notice how many x-intercepts does it have? It has 2 x-intercepts this time, right? And it has 1 y-intercept actually. So there are the 5. And then we have 1 minimum point right there. And so the shape of a cosine looks like a cup. And that's the end of the lesson for today. You may go ahead and get started with your assignment. See you next time.